In this video, we will discuss about the model paper number 5. Then question number 1, a box is kept stationary while applying a horizontal force when it is placed tightly with a vertical wall. According to the description, the figure will be here the object here the object placed tightly with the vertical, here the vertical wall, then a horizontal force F is applied on the object. Another force will be weight. Then here the weight should be balanced by another force. Then what will be the another force? Then friction. Here friction force will be in upward direction. Then friction force, the minimum frictional force will be equal to the minimum frictional force that should be exerted on the object should be equal to its weight F equals mg. Then normal reaction from the wall will be equal to, according to the horizontal equilibrium, R equals mg, R equals F. F means applied horizontal force. You know that for the limiting, here this frictional force will be equal to limiting frictional force. Because this will be the minimum frictional force that should be exerted on the object to maintain the equilibrium with mg, limiting frictional force. Then limiting frictional force F equal mu r. Here limiting frictional force should be equal to mg and mu into r should be equal F. Then mu equal mg over F. But you know that here mu should be lower than 1. Then mg should be mg over F should be lower than 1. Then mg should be lower than F. This will be the requirement to place the object tightly with the vertical wall. Then the answer will be answer number 3. The weight, the applied horizontal force should be greater than the force that is required. That means if the force that is required to keep the box is greater than the weight of the object. If the wall is smooth, then this object cannot be whole, cannot be maintained in the equilibrium. Okay, if the wall is smooth, then the object will slide down. For any force we apply, any force of F, any value for F, then object will be slide down, cannot be maintained. According to second question, here 3 masses M1, M2 and M3 have been tied on a roof of a train wagon. Here I am taking an object of mass symbol M. Hanging on the roof by a lightweight string, and the system is accelerated along the horizontal direction. Then the string will be tilted at a certain angle. Here the object weight will be exerted mg, then tension T. Then consider the equilibrium, vertical equilibrium of the object. Vertical equilibrium T cos theta equal mg. Answer. Equation number 1. according to the F equals ma, apply F equals ma, then horizontal force will be T sin theta. Here T sin theta equal ma. Second one. Then we divide 2 divided by 1 T sin theta divided by T cos theta equal ma over mg. Tan theta equals a over g. According to this relationship, here the theta depends only on the acceleration of the train vehicle, acceleration of the system. Okay, does not depend on the mass. If the mass is m1, m2, m3, and the system is moving under uniform same acceleration, then the inclination will be equal. Inclination of all the strings will be equal. Then alpha equal beta equal gamma, because the angle doesn't depend on the masses. Okay, then answer number 2. Question number 3. Here this G is a source and D is a detector. Okay, the sound waves emitted by the sound source G will be moved in 2 paths. One in linear path and second one is the semicircular path. Okay, here the sound source G emits sound waves, then moves in this path, and other waves are moving in this direction, this path, circular path, and then come to the detector. Here asking about the 2 paths travel along the semicircular and linear path, then it finally reaches D as a complete wave. Because of 2 waves are interfered, a complete wave is formed according to the interference. If the detector should not detect no sound, here no sound means after the interference occurred, there is no sound detected by D. Then there should be destructive interference. Destructive interference should be occurred. Interference should be occurred at the point A, at the junction. Then for disruptive interference, for constructive interference, this difference of distances of the path should be equal to lambda or whole number multiples of lambda. Okay, then for disruptive interference, the difference between the distances, lengths of the path should be equal to lambda over 2. Here the difference of path, here the length of the path will be semicircular path will be phi r, this path will be r 2r, then phi r minus 2r, this will be the difference between lengths and distances. Lengths of 2 paths will be equal to lambda over 2. Then destructive interference equal. Then phi minus 2 r equal lambda over 2, here r equal lambda divided by 2 into phi minus 2. This will be the answer. This will be the minimum radius of the semicircular part. Then answer number 2. Then question number 4. The following graph. This graph shows velocity time graph for A and B. Two vehicles, A and B. B is a police bike and the A is motor vehicle. Initially B was at rest. B means police bike. And was at rest and started its motion to chase a motor vehicle A that passed B. At the instance where B catches A, what will be the displacement of A from the initial position of B? Okay, here two vehicles are started at the same point because the object A that police bike starts කියන්නේ මේ police bike එක start කරා යාගේ motion එක start කරන්නේ පුතේ හරි හරියටම එයාව ඒ කියන්නේ car එක pass කරලා යද්දි motor vehicle එක pass කරලා යද්දි police bike start its motion just after it passed it passed by the just past the here question number 4. The following graph shows the velocity V, velocity time graph for a police bike B and a motor vehicle A. Initially B was at rest. Initially B was at rest and it started its motion to chase the motor vehicle A that passed B. ඒ කියන්නේ මෙතෙන්දි කියන්නේ motor police bike එකේ motion එක start කරනකොට ටික වෙලාවකට පස්සේ කියන්නේ ඒව pass ඒ කියන්නේ motor bike එක police bike එක car එක pass කරලා ගියාට පස්සේ තමයි මේ motion එක start කරනවා කියලා කියන්නේ. At the instance where B gets A, what will be the displacement? What will be the displacement of A from the initial position of B? Initial position of B. Initial position of B. Okay. Then අපිට පේනවා මෙතනදී VT graph here. This will be the velocity time graph for A. A means motor vehicle. Its velocity will be 20 ms minus 1. B starts its motion after 5 seconds and accelerated up to 15 seconds, then moves under uniform velocity at a certain instant. Police bike can catch A means motor vehicle. Here assume the time for this motion is T. After police bike comes its uniform velocity, then the time for catch A is T. At the instant where two vehicles meet together, the displacements should be equal because the two vehicles start this motion at same place, same position. Then at the second meeting point, the displacement should be equal. Okay. This will be the meeting point. Okay. Then the displacement of car, motor vehicle, displacement of motor vehicle. A should be equal displacement of B. Here displacement of A equal 20 into T plus 15. Equal displacement of B equal 25 into T plus half into 25 into this will be 10. Then T equals 35 seconds. Then we calculate the distance from the initial position of B to the meeting point will be equal to displacement of B. Here displacement of B. Then this one will be equal to 25 into 35 plus half into here half into 25 into half into 25 into 10. total displacement will be 1000 meters. This will be the displacement of B from the initial position to the meeting point, catching point of the motor vehicle. Then answer number 5, 1000 meters. Question number 5. Here the answer number 1 should be corrected as 1.4 root 6 should be corrected 14 root 6 centimeter cube per second. Centimeters cube per second. You know that the flow rate Q equal cross-sectional area into velocity. Then velocity equal flow rate divided by cross-sectional area. Here the area of the mouth of the tap will be equal to 1.4 centimeter square. Then the velocity will be here Q divided by 1.4 after certain distance means 45 millimeters. 45 millimeters means 4.5 centimeters. The cross-sectional area of the water flow will be 0.35 centimeters square. Then the velocity will be Q divided by 0.35. Q divided by 0.35. This will be under gravitational acceleration. Then motion equation can be applied. Downward V squared equal U squared plus 2A. Here Q divided by 0.35. Final velocity will be Q divided by 0.35 squared. Q divided by 1.4 squared plus 2. Here the acceleration in downwards gravitational acceleration should be substitute as in centimeters. 10 ms minus 2 meters per second. Centimeters should be converted into centimeters. 2 into 10 into 10 to the power 2 into 4.5. After resolve this, then Q equal 14 root 6 centimeter cube per second. Answer number 1 should be corrected. 1.4 should be corrected as 14 root 6. Okay, thank you.